Hello everyone, Rick here from Cronos Labs. So today I will walk you through some of the updates of our Cronos Play SDK, and more specifically I want to guide you through our documentation so that you have everything that you need to build your next gen game during the ETH hackathon in India. So what you will see here is this is the main path of the documentation. If you visit our docs.cronos.org, you will obviously have many other tabs, but I guess the one that is relevant for the specific workshop is called Cronos Play, and maybe a couple of words about what Cronos Play really is. So in a nutshell, it is a gaming SDK that we have been preparing together with ChainSafe, and it essentially connects the world of gaming with Cronos. So it allows you to integrate your next generation game or any game that you might be working on with Cronos, and then ultimately really help you to create seamless experiences for the players that might be playing your game in the end. So a couple of things that you will be able to do with the SDK. Obviously, you will be able to connect and interact with the Cronos network, but you also will be able to provide in-game NFT functionality as well as the ability to use authentication modules with different wallets. And I think another very important point is that we do not only support Unity but also Unreal and C++. So a couple of things to bear in mind. What I want to do is I want to walk you through every step from start to finish. You might have already some familiarity with Unity. If you don't, that's fine, because the purpose of this workshop is really to pick you up from step one and walk you through to get you started with the Unity Cronos Play SDK. There's a couple of things that we will be doing. Obviously, whenever you get lost or whenever you have some questions, you can always consult our SDK. It really has the steps that I will walk you through today. So I think it makes sense to familiarize yourself as well with the SDK. So first things first, the tab that is the most relevant to us is the Unity tab. So obviously we are assuming here that you have a basic understanding of Unity. If you don't, that's okay as well. Also, to have some ERC 721 and EVM practices would be a good prerequisite to have. If you don't, again, it's still fine. But yeah, so the supported operating system for this is for this specific workshop, I'm going to use WebGL. But you can obviously also explore the possibility of iOS and Android builds. Then what we want to do is there's a link so you can go ahead and download the Unity SDK. You can either follow this link, go to the official Unity website. It's definitely a good way to get familiarized with the SDK, with the Unity framework as well. Now, for example, if you would be running on a Windows machine, you would go for the Windows version. If you're running on a Mac machine, you would go for the Unity Hub version. You just have to choose the one that's right for you. Then another thing to bear in mind, if you were to use the RPC methods, you can always switch between the mainnet RPC method and the testnet RPC method. Now, the news from quite a couple of weeks ago is that now we support the subgraph and we have deployed our subgraphs, which means that in theory there's no need to use the RPC method in the development mode anymore. But I will show you a couple of examples just in a couple of minutes. So there's two ways of importing the SDK. The first one is by either using GitHub, to clone the repository into your machine, or you just can go ahead and download the latest releases from ChainSafe, from the SDK. And once you have downloaded it, the first thing that you want to do is you want to import it into your let's say project. If I were to create a new project, then I'm just gonna leave it as it is. I'm just gonna show you what happens here. So all you want to do is creating your project, and once that is created, it's gonna take a couple of seconds. Once that's created, I want to copy or import the library and the package that I just downloaded here into my asset folder. And voila. This is as simple as it is to import the SDK into your game build. Let's just close this for a minute and go back into the documentation. So before even starting with the few examples that I have prepared, I want to quickly walk you through the documentation. So the first one is EVM. So what this is, it's really a standard interface for EVM methods, and there's a couple of methods outlined here in the section. For example, the player account, the player prefs get string is basically the one that will help you retrieve the address from your wallet once you log in through your wallet of choice in the game scene. And basically, obviously, we can use hard-coded account by just copying our account address, but using the player pref get string method is basically dynamically fetching the equivalent account address that we have in our wallet. Then we can use the block number, which is basically going to get the current latest block number. Obviously here you can see you can switch between mainnet and testnet. And yeah, once we create the integer for block number, then we await the promise of the EVM method, and then we basically pass the chain in the network. And if you want to print the block number, it will basically return the block number, the current latest block number. Then we can use balance off, which is basically getting the balance of Cronos that is related to a specific address that we have and a specific network that we have. So for example, if I wanted to know what my current address is, once I log in, I would basically pass in here my wallet address, or as I mentioned before, the player prefs get string method in here. Then we also can use the verify method to verify assigned message. So basically what you do is the evm.verify method, we pass a message and a signature, which we define in here, for example, and it then returns the address of the verification with the message. We also can print a nonce if we needed a nonce. In this example, we're using the RPC method, but as I mentioned before, we don't need to necessarily use the RPC method anymore. So this is optional. If you prefer to use the RPC method, you can. If you prefer to use the subgraph method, all you have to do is remove the RPC option in here. Also, something that might come in handy is a way to convert your way to Crow and vice versa, and that's the option to do that here. Basically, you will find it under the EVM method. Now for ERC 721 contract tokens, basically there's a couple of methods that you can use, such as the balance off, option that is basically going to count all the ERC-721 tokens that are assigned to one specific wallet address. And then we can use as well the owner of method, which is basically a way to find the owner of a specific ERC-721 token. And here the option that we have, again, chain, network, contract, and token ID. And then we want to verify the ownership by passing the chain, network, contract, and token ID into the owner of function of the ERC-721 method. Now we can also use the owner of batch method basically to get a balance of the batch and the list of a specific set of token. And the way we do this is by creating a specific list in here with different token IDs. Then we have the URI. So this basically returns the metadata of a specific token, and we will have a look in this very shortly as soon as we jump into the Unity editor, because this is something we will be using when we want to replace, let's say, a game object with the data, the raw image data that comes back when querying for the URI. And then the last one in here is the method that gets all specific ERC-721 tokens that belong to a specific address. Now, there's a couple of other options like ERC20, custom RPC, and also some login, some examples such as the login example and other useful links, and even a 2D game example that might be helpful. But in the interest of time, what I want to do now is I'm going to close what we have in here and jump directly into the Unity editor. So all you'll see here is I prepared a couple of game objects with a couple of scripts. So if you go to the first one, that is basically, as you can see in this code snippet here, where is it? So it's called ERC-721 balance of Cronos. I think it's self-explanatory what it does. It basically is the one method that we use to get a specific balance of NFTs that belong to a specific address. In this case, it's my address. It's one of my test accounts, test addresses. In here, I put in the NFT asset address, and also the network, which is testnet, and Cronos. So this is actually very cool, because before I go ahead, I want to show you something. We have a faucet that is quite helpful. So whenever you want to create an NFT, a test NFT on testnet, you can do so by visiting our NFT faucet. So I'm going to open this now. So as you can see, that's the website. All you have to do is you connect with your address, and it's going to take a couple of seconds to load. But essentially what will happen here is it gives you an option to create your specific NFTs, description, attributes, and also an image file that you can upload. And once that is created, you can basically use it to create test NFTs, which I have done. As you see, there's a lot of different NFTs and helmets that I'm using in Unity. So I think that's quite cool. That's something you can test as well when you want to create some test NFTs. Okay, let's go back to our Unity editor. So let's try to run this script. I'm gonna unmute it. So this is going to return the amount of NFTs that I'm owning. So there's around 4 NFTs, okay. So next thing I want to do, I'm just going to stop this, mute this again, And then we jump to the next method, which is going to check for the ownership of a specific NFT. I don't know what happened here. Yeah. Okay. So in this case, I'm using the RPC method, as you can see. This is basically the way the SDK was working for Cronos before. But since we launched the subgraph, we don't really need this part anymore. But let's just use it to give you a sense that both options are actually possible. And what this will do, it will print the owner of token with the ID 53. And here we go. Yeah, I can confirm that's definitely the address that I used, so that worked as well. Okay, I'm gonna stop this again, untag it. And the next one that I want to check is the balance of Cronos, the EVM method. And in here, again, all I'm using is the option for chain, network, and account. I pass them into balance off. And then whenever I print, it should print my current balance of task row in wave format. And that is correct as well. I'm gonna stop this again. And now I want to actually test something that I mentioned before, how to import NFT texture into the game. So what I did here is I created a quad game object, and then I assigned the component, the script component, to import the NFT texture, which you can check out here. So there's a couple of things that I've been setting up here. I have a response with an image, which I'm going to use in my Unity web request. So what happens here is we have 4 options: Cronos testnet, the contract ID, the contract address, and the token ID. Then we have the URI from which we will get the specific. So basically, this is our URI that will be generated once we pass the chain, the network, the contract, and the token ID, and we query for this information, and it will return the URI if it is available of the specific metadata. And what we want to do here is a little condition. We want to check whether the URL, the URI starts with IPFS, and if it does, we want to replace it with the HTTPS protocol to ensure that we don't have any strange error logs when we try to retrieve the data. So next step is we fetch the JSON from the URI, and then basically we start our, this is how we start our Unity web request. It's a GET request, so we get the URI, we await the web request, and then we create a response data object. And in here, we basically going to use the JSON utility to download the data that will contain our response, and more specifically, it will contain the image URL. And here again, we want to make sure, obviously there's a bit of repetition here in a real world scenario. We would try to reduce this in a smarter way, but essentially we want to check if the image URI starts with IPFS, and if it does, we replace it with the HTTPS protocol. And then ultimately we just fetch the image and we replace the empty game object with the image texture. But let's have a look and try to see how this will look in action. So if I run the script, it just imported the image that I created before some time ago by using the NFT faucet, which I showed you a couple of minutes ago. Okay, so how can I actually make sure that I can display only NFTs that belong to my address? So the last option will answer that question. It's a login example. It's a little bit longer, but essentially what the login example does, it basically makes use of the player prefs get string method, by which I retrieve them, the account once I log in with my wallet, and I want to make sure that the owner of the specific NFT and the account owner are the same. And if they are, if the condition turns true, then I run exactly the same script that I just showed you. So if you were to do this in a real example, obviously, okay, this is set up. I can try to just create an example login. So we have the web. So click on build and run, save. And what I want to do now is I click on login, select MetaMask, and here we go. I basically authenticated with my address. I made sure that my address is the same as the account that owns this asset, and if the condition turns true, it basically loads the asset into the game by replacing it with the game object. Okay, and with this I want to conclude this workshop. If you have any questions, please feel free to reach out. You will find most of the information on the documentation, but we are here to help, so any questions, just let us know. Thank you everyone. Bye now.